Hey everyone, I'm Michael Hall, and this is Innovation Coffee brought to you by ARM, where every week we give you a deep dive into the ARM developer ecosystem with special guests and topics that bring you the latest innovations that are happening in, on, and around the ARM architecture. And remember, Innovation Coffee encourages audience participation. So if you're watching this live on YouTube right now and you want to leave a comment or a question for us to bring up in the show, just go ahead and put it in that YouTube chat and we'll see that and we'll bring it up as soon as we can. This week, we've got another great episode. We'll be joined in a little bit by Duncan Hardie. He's a senior principal product manager at Red Hat, and he's on here to talk to us about their product OpenShift, which is a cloud orchestration platform, and how you can use OpenShift to deploy your cloud applications on ARM nodes. But before we do that, if you like this show and you don't want to miss future episodes, make sure you hit that like and subscribe button so you always get the latest updates on broadcasts that we're doing, Innovation Coffee, ARM TV, any of our special brew episodes that we do. So again, hit that like and subscribe button and you'll be able to see that. And if you missed last week's episode, we had Kunal Pethek from Microsoft on talking about optimizations that they're doing inside the .NET framework to make that run faster on ARM by using ARM intrinsics, which are the optimized instructions for things like scalable vector extensions, which let you do multiple processes on a set of data with a single instruction, all kinds of stuff, and the improvements that made to the .NET performance. So if you want to see that, go ahead and check out that episode. Here's the link below, and you can watch that. And you can watch this one as well afterward the show. We'll share the YouTube link for that. This is our last episode of 2023 because we are getting to the end of the year and all of us are going to be off next week. But we will be back first thing in the new year. January 4th, we will have our next episode, so be sure to stick around for that. All right, I think it's time that we bring on our guest, so help me welcome Duncan Hardie to the show. Duncan, how are you?
I am good, Michael. Nice to meet you. How are you doing?
I'm doing excellent. Ready for a little bit of Christmas holiday break. How about you?
Yeah, I can't believe they give you holidays based in the US. I thought it was only Europe where we get
Well,
time off. So,
ARM's a UK-based company, so I get all those wonderful European benefits.
of course. How could I forget that?
So, Duncan, before we get started, please tell us a little bit about yourself and how you got here.
Wow, yeah. So, despite me looking so young and wonderful, I've been in the industry for way too many years for me to really talk about. But I've been a product manager for about 20 years now. So, lots of fun had there. Started out in the early days of containers, working on Solaris, worked for various companies. So about 5 years ago, I started with Red Hat. I'm based in Scotland, by the way, so apologies to everyone for the really bad accent. I'm sure there'll be subtitles available for people later on. And yeah, at Red Hat, as product managers, we tend to get a chance to look after different engineering teams. So I started with storage, I played with Federation for a while. I did some work with what we call a cluster infrastructure, so all the kind of inside machine APIs and things like that. But right now, I've got two engineering teams that I get to play with. The first one is Windows containers, so not a lot of people realize, but you can run Windows nodes in an OpenShift environment, so I get to play with that. And the reason why I'm chatting here today is I also get to play with what we call the systems enablement team, and they look after everything that doesn't run on x86. So ARM is obviously at the top of our list there, but we also do look after the IBM systems, so IBM Power and IBM Z. So anything to do with a non-x86 platform tends to come our way.
That's awesome. So we have you on here today specifically to talk about OpenShift. And before we go into detail on that, can we start from the beginning and what is OpenShift and where does it fit into the whole cloud native Kubernetes kind of ecosystem?
Yeah, so one of the early days when I started, and a big misunderstanding about OpenShift is a lot of people think that it's just a Kubernetes port, orchestration tool that we're all very familiar with. That came from Google, allowed you to kind of throw lots of workloads on there and run it across. And we don't call it OpenShift Container Platform just for kicks and giggles, really. it is a full platform. So we do have the Kubernetes layer in there, but there's a whole bunch of other stuff around there. So we'll help you install, we'll help you set up your network, and we'll manage the underlying OS underneath. We'll have things like that sit on top of the like support for serverless environments and support for things like service mesh if you want to do cool things with your applications and networking, and then a whole bunch of management tools around that and security tools and everything. So it really is kind of your full solution. And what we like to think about OpenShift, and this is why it's super relevant to ARM, is that we want to give you the same look and feel, the same experience, regardless of the platform or the cloud that you're running on. So, you can run OpenShift on bare metal, you can run OpenShift in AWS, in Azure, in Google, IBM Cloud as well. It's all the same look and feel. And as far as the architectures underneath, as I've just said, you want to run it on x86, yep. You want to run it on IBM Power Z, yeah. And more importantly, you should be running it on ARM, and we absolutely do that today.
So it's not just a product then. You've got a whole set of services around this product that Red Hat offers?
Yeah, and we talk about kind of two ways to run OpenShift. So there's open. I'll get wrong for saying this, but what the heck? We're amongst friends, and it's nearly Christmas. There's OpenShift for the brave, which is what we call the self-managed option. So that is you still got all the tools, but you kind of look after it yourself. And then we've on top of that, the interesting area for us right now is what we call managed services. So if you want to run an AWS or Azure or Google, for example, you can work with Red Hat and we'll kind of take all the pain and day-to-day management of the infrastructure off you and do all that for you and just let you concentrate on top. So there's lots of ways to consume it. And it's really, again, I'll keep coming back to this theme so much that you'll probably get sick of it. But it really is about, this common look and feel experience. So you don't really get locked into any environment that, again, at ARM, you're probably very well, actually not so much now because you've made some great strides with the chips. So, but in the old days, the early days of ARM, when the Graviton 2 days, there were certain workloads that probably suited to the Graviton 2 chip. And you want to run some workloads on that, and you might want to use other architecture or other ones. So OpenShift was kind of this layer that sat over the top that just made that experience the same and that much easier for you. Of course, you've made our job much harder now because I'm hearing great things about the latest chips that you've got that just run everything really well. So it's like, if you want to do that with OpenShift, sure, come along.
Yeah, yeah. Apologies for that.
No, this is good. This is good. I'm sure you know him very well. John Masters was the person that made me drink the Kool-Aid about ARM about 2-3 years ago, and I'm gonna get a T-shirt saying this is the year of ARM printed. I'm pretty sure, but it just feels like everything is aligning right now. It's really good to be around.
Yeah, we keep trying to get John to come on our innovation coffee. I stumbled across something that he did probably like 10 years ago now, where he had that bicycle powered
Oh yeah,
server
yeah.
made up of Raspberry Pis.
Yeah, there was yeah, I can't admit that I have his imagination at all, but he definitely was, I think he's at Google now, isn't he? But he definitely, when he was at Red Hat, he was a great advocate for ARM. So it's good to
Yeah,
see
it
things just
still
really
is.
taking off. Yeah.
I actually, he just posted that he was at our Cambridge office just recently, so he got to meet some of the folks there. Unfortunately, I was not there, so I couldn't rope him into doing innovation coffee.
Next
But
time.
sooner or later, we'll get him on. We got our first question in the chat, actually, from Leon, who says, "Hi, what OpenShift flavors are out there for a local cluster?" So I'm assuming that means running on bare metal.
Yeah. So there's a lot of different options there depending on what you want to do. So you can there is something actually which is aptly named OpenShift Local. So that's kind of a pared down OpenShift that you can allegedly run on your laptop. Now, again, I need to be careful here. I wouldn't really be advising you to do that because it's going to be, even though you're just going to kind of play with it on a laptop, it's not going to be the best experience because we do have decent memory requirements around OpenShift. If you've got a pretty chunky one of these new ARM servers that are around, then that's probably a better bet to try that there. So you can do that. You own your own instance and do it. And we do have kind of an online sandbox that you can play in as well. So shift and see what it's like. You can get online. I can't remember the URL off by heart right now, but I can stick it into the chat later on. And that will give you a fully online OpenShift instance with everything that you need installed. So you can try that free. I think it's either 60 or 90 days that you can have a play with that. And then if you want to keep going, then you can add a subscription to go with it. And then there's the a full version works on all flavors of hardware that we support. So if you've got a bare metal environment, you can go and try it. And it is just OpenShift. It gets kind of interesting because about 2 years ago, we introduced the idea of what we call an OpenShift Platform Plus. So I live in what we call the core team. So that's kind of your networking, your storage, the orchestration pieces, etcd and all those types of things. But outside of that, we've got other areas that we call the layered products. So that's like OpenShift Serverless, Service Mesh is another example, OpenShift Virtualization. They kind of sit on top, and then the piece right at the top is part of this Platform Plus suite. So that's a whole group of kind of major apps that you want to use in your environment. So probably my personal favorite, though I'll get wrong off the others for saying this, is what we call ACM, which is Advanced Cluster Manager. That just manages your environment for you. So you can have multiple clusters in there if you want OpenShift clusters that it will deploy and manage and do a whole bunch of stuff on. The one that's getting the most attention at the moment, for reasons we will all understand, is our Advanced Cluster Security tool, ACS. So that's all about your security needs, from doing checking of binaries or images that you've got, through to sign-in, through to policy management of your network. So, that's pretty key in your environment. What else have we got? ODF, OpenShift Data Foundation. So that's the storage piece that we have. So that's a kind of Ceph-based storage, but you can expose it actually as a file system if you want to. And then you wouldn't be anything without images, so we have something called Quay. So depending on how much you want to play, your person asking the question, you can have a double at the bottom with OpenShift Local. You can go and try a bit more just online quite easily with our sandbox environment, or if you really want to, you can go and get the whole kit and caboodle. And I'm sure there'd be a Red Hat associate that would be quite happy to talk to you about our subscription models that we have.
We'll get that link to that sandbox from you and make sure that we put it in the video description once we upload all this to YouTube.
That'd be great.
So there's a lot of products out there built around OpenShift. It's not just the one thing. And it's not a new thing either, right? It's been around for a while. Can you tell us, briefly, the history of OpenShift?
Yeah, so OpenShift, when it first started, wasn't actually Kubernetes based. And way before my time with Red Hat, they made the decision to move over to that. When I joined as I said, 5 years ago, we were coming to the end of what we call, what was our 3.11 release. And that was interesting times. The industry was really taking off. People were using it. But there were, various issues and problems that we saw in the environments that kind of made it interesting. On our side, it was all around upgrades and installations. So the experience that back then, and I can say this now because we've improved on it, was not great. So what we tended to see was, customers would typically install 1 or 2 or maybe 3 clusters and then just stick with them and just grow them out. And this was because they were so difficult to maintain. Upgrades broke, not just because of us, even upstream with Kubernetes, APIs would be broken and things. And then about 4.5 years ago, we moved over to our 4 release. So we've just had, to give you an idea how long ago that was in release time, we've just had our 4.14 release on October 31st. And that for us was a big architecture change, just to make that installation and upgrade procedure much smoother. And we've worked hard at it. And I hope our customers agree with us that it's a much smoother thing. And we've seen the impact of that. So like all companies, if you opt in, we collect telemetry. And we've seen a change from, customers that had 1 or 2 or 3 clusters in the past now have maybe 10. The clusters that had 10 clusters are up to 50 clusters. So, and that's partly on the back of these things are much easier to create and much easier to upgrade. And we've got some, interesting technology in there just to make sure that it all, called operators that we based it on, that basically just makes sure that you can upgrade while you're still live. We'll go out and roll across your cluster and, you'll get with a new version. So we've seen a big shift from people quite rightly just sticking with something that works to now, we've got a lot of our customer install base are on the latest release, which is, good from a feature side from a product manager, but also just picking up all the security bits and pieces that you needed as well.
Yeah, and as a software developer, just knowing that those upgrades can happen, they can happen safely and smoothly, and you like a lot of times people they play it safe by sticking to something old because if it's not broken, don't fix it, right? But then you kind of get left behind in terms of features and more importantly in terms of security fixes as well. So
I think that's so that's one of the benefits stroke curses of something that ARM we're seeing being used everywhere. OpenShift gets used everywhere, so it's interesting in that you have some industries that are really ready just to take change on board and go for it, and then
mhm,
you have others where they kind of make it really difficult. So, a hypothetical situation is we have something called OpenShift Device Edge, which is aimed for it's like a slimmed down OpenShift version for the edge where ARM rules, right? And for that, when you look at upgrading that thing, it could be something that lives in a telco box somewhere in a tower network. So you're going to have, I don't know, 4,000 of these in a region in a state. So even if an upgrade just takes 5-10 minutes, you're talking about an immense amount of time that you've got to go through. So those customers, need a longer support tail. So as of the last release, we actually updated our support tail to be now. I need to be careful here. I think it's 2 years right now, so you can have
mhm.
stay on a release for 2 years. But as you said, there's other customers that are like, yeah, let's go for it. As soon as 4.14's out, we're getting well. I had a new release on Windows containers that had cluster something called cluster-wide proxy support, catching up on the Linux side of the house, and we had a support call on that within 2 days of the release coming in. So it's good to see customers kind of adopting it quickly, which is what we want, right? I don't know about you, but my epiphany moment was I was sitting, and this was a long time ago, maybe 10 years ago. I was sitting in a talk once, and it was an HR tool that was web based, and they would just talk about rolling out new features without the users even knowing about it. So your user was on, and suddenly a button would appear, and we're all kind of more familiar with that now, but that whole idea that new stuff can appear without outage is like really nice goal to aim for. So that's where we're kind of going.
So 10 years ago, servers were really pretty exclusively x86, right? So when OpenShift started, it was, I'm sure, focused just on, x86 servers. What made you decide to start investing in supporting ARM?
So that's a good one. So I, I don't know whether you see it this way, but I definitely see us as one of the early adopters of ARM. So we actually did a dev preview back in July 2021. And there's a good little, let me, before I answer your question, let me do the typical product manager thing and go on the side, but remind me come back. What was really good about that dev preview was, and I can let this secret out of the box now, it was based on OpenShift 4.9, and OpenShift 4.9 wasn't actually due to ship until October, but we found the experience of moving to ARM so easy that we actually managed to get the work, and the team were talented, don't get me wrong, but we got the work done in about 3 months. So anyone that did actually try the dev preview actually got an illicit early version of OpenShift 4.9 before it came out. So that was really good. The reason we tried to do it was just, we were talking to yourselves about the stuff that you were doing. We were seeing what was happening with the chips. At the time, the thing that grabbed our attention was the performance per watt, and we couldn't see a space where customers wouldn't be adapting this. And it was almost like there were a few things that were aligning for us that we looked at. So it's I used to work with hardware, so I always work bottom up. ARM came along and you had the chips, but you didn't really have any hardware or service for a while, and then you just went and owned the cloud, and then Apple did their thing, and then Ampere came out with a good server. So that was kind of happening when we were looking at it. And likewise, when we were talking to customers, they were kind of starting to talk about, there's kind of three areas. Again, I'm kind of digressing a little bit. Hopefully, this answers your question. There's three kind of areas that I saw them getting traction on. So the first, I'm going to leave the first one actually and do it last. The one that kind of tickled us at the time was the eco. So because you had such great performance per watt, there was customers that were signing off on their eco credentials, and they're like, how can we do this in an environment really easy? So we saw traction there. there was obviously the edge devices. So there's certain customers that we talk to that do testing on their edge devices, and they want to kind of bring that into a server type environment, so it's all integrated and use OpenShift to schedule across it. And then, of course, around that time as well, we were seeing specifically on AWS the innovation that we were doing with Graviton, including kind of, and I know this has changed, but initially financial incentives to kind of use ARM, equivalent for equivalent. When I first started out, was an ARM instance was about 60% of what an x86 instance was. So, that's a great argument for kind of looking at it. So it's always difficult with software and decisions like this, as I'm sure you're aware, having talked to lots of partners about when I'm going to use the phrase, when do you jump on the bandwagon? And there was a good decision within us to get there early. And the good thing was OpenShift is built on RHEL. So we have something called Red Hat CoreOS that sits in there, but it's just a version of RHEL. And the RHEL team had done all the work already. So that was kind of sitting there ready for use. And as I said, for the effort that we put in, it looked like a great thing. And we had some bites straight away on the back of that. So that's kind of why we kind of went and did it.
You mentioned earlier all of the different products that are in part of the OpenShift platform. How many of those are working and supported right now on ARM?
Now you've hit on my daily battle. So we haven't got the whole stack on OpenShift, the whole kind of OpenShift platform plus running on ARM yet. There's again, I guess this is one for after the show, though I do have the link handy. There's a link that we do where we kind of list out what things we do support, because customers kind of ask about that. We have, as far as the core side, we're done. We were done when we GA'd, I think it was March 2022, was it? Let me just double check. Yeah, March 2022. So we were done with the core, all the core pieces worked. And then what we've been doing is slowly bringing in things. So OpenShift GitOps, they recently made, I'm saying recently, 9 months ago, made their stuff available on ARM. But there are a few outliers that we're still after. The ACS, the Advanced Cluster Security stuff that I was talking about, that's not there yet. But we're looking, if you look at our longer term roadmaps, or it's what we call a midterm goal. Likewise, another one we get asked for is OpenShift virtualization. So we're not there yet with that yet, but that's again something we're trying to bring along. And then there's some things that are a little bit further out, but the majority of the stack works. When you look at what the use cases that we are seeing right now, you're good to go. And then things that are kind of missing. So ACM, for example, that does fully manage ARM-based clusters now anyways, but even if it didn't, you could run that on another system. Probably the better example is Quay for your image registry. So you could run that on an x86 system, and then, where you're really worried about your workloads going fast or being power efficient, and you can run those on the ARM side.
And you wrote a blog post with that March 2022 release, right?
I did. It was terrible. I was rereading through it and prep for today and saying, have you ever said anything stupid? Yeah. But that's one of the things, I guess, since you've touched on it, that's one of the things that hopefully, viewers will see next year. We're going to do, the plan is to try and do a big push around the ARM stuff, particularly with a focus on the application side, because I think, I was kind of talking about this before. You brought the chips along, the hardware came along, the middleware pieces are starting to fit in with things like OpenShift. That, the questions that we're getting now, which to be fair, you've done great work on, is just the stack that sits above that, or how you get onto ARM. So we're looking at what we can do around, a blog on our OpenShift Pipelines product, which is like a CI/CD infrastructure based on Tekton. Also around our GitOps. So kind of doing some messaging around that, so you can, much better answer your question earlier about how do I get onto ARM and start using it with OpenShift, with a blog with some references and some tools to get you there.
So a lot of times when I talk to application developers, they tell me they want to start running on ARM, but they're not sure how to get started or what that kind of workload is going to be. So like they've got this aspiration, but they kind of get stuck there. What would be the process if somebody has like they've already got some software written running on OpenShift? what would be the process for them to start using ARM nodes as part of their OpenShift deployment?
Oh, nice, nice. So you're giving me an opportunity to segue into one of the features I own. So let's start with the kind of plain thing. So I think what we're seeing right now um, is that customers that want to adopt ARM and move on to it. So ARM's in all the clouds that you want to run on right now. And what we're seeing is kind of a double jump. So customers that want to adopt ARM are doing this double jump. They're moving off x86 onto ARM and then moving into the cloud straight away because it's easy then. I mean, it's not the case now, but definitely for us, it was problematic to get, even for us, just when we were doing testing, it was problematic to get ARM hardware in the early days. That's
Mhm.
not the case anymore. Um, but I think that's kind of what we see because people often think it's kind of our customers are just going to jump and change instantly. It's not. It's kind of usually a multi-month at least, if not a multi-year kind of thing, just for the planning, not the actual instigating it. So we're seeing that one jump, and I think that's kind of the first wave. The second wave that we're kind of wondering if we're going to see right now, and this is, this should flop out next year, is customers that want to move over, but they don't want to do everything in one jump. So for my sins, I used to be a consultant, a professional services consultant. And the projects that always really got me worried were the really big ones where they were going to change everything on January 1st. It was like, yeah, we're going to rebuild the Titanic, right?
Yeah.
So there's a lot of customers where they want to kind of maybe take some baby steps. Um, so in OpenShift, what we've given you is a couple of routes to do that. So the first one is the idea that we're seeing actually generally outside of ARM, but could also be used in the ARM space is the idea of multiple clusters. So you'd use something like Advanced Cluster Management Manager, like ACM, to just spin up an ARM cluster, and then all you need to do is, I'm saying all you need to do is, well, it is kind of all you need to do. I've seen how successful this can be is just recompile your application to run on ARM and then feed it in. So everything that you'd set up within OpenShift, so whatever rules you've got, whatever security rules you've got, that's all the same. You've just got an ARM cluster. So you just say, okay, run these jobs in this cluster and you're done. We are offering something else now. So this has been around for 2 releases now, and it's what we call multi-architecture compute. And what that lets you do is the way OpenShift was written was that it always assumed that a cluster was of a single architecture. So we went away and changed some things. So now you can mix architectures into OpenShift. So you can have, I don't know, let's just randomly say we'll start with an x86 cluster, but as what we call a day two operation. So that means after you've done your installation, you can start adding ARM nodes into the mix. Now, what we're looking for is to see if that's really interesting for customers that want to adopt ARM. And I very much get the feeling that it's a one-way track, right? So they want to get to ARM, but there's only certain things that they have maybe the time to do, or maybe the less risky things that you want to move across first and
Yeah.
see whether it works. So
Don't want
so
to
this,
rebuild the Titanic, right?
yeah, exactly. You want to start by maybe putting some iceberg defenders on or something like that. So this technology will let them do that and move across. Um, the other stuff that we see that's going to be really interesting, I think, and again, I'm kind of diverting from your question because I'm an annoying product manager, and all you have to do is just
That's fine.
recompile,
No,
right? Yeah,
answer however you want.
it's like you just need to recompile, right? And then everything, again, to go back to my original message, everything else is the same. So if you're used to OpenShift, recompile your apps, get your ARM nodes, and you're done. But the other thing that we're kind of seeing that could be quite interesting is we have this technology called hosted control planes. And I'll get into what that is in just a second. But if you look at the industry today, when I first kind of started at Red Hat, it was like everything's going to be in the cloud, right? Everything's going to be in the cloud. Everything would move, and as usual, there's no extremes in IT. The answer's always somewhere in between. So
Mhm.
you've seen customers that have adopted cloud, some that have stayed bare metal, some that have moved to cloud and then brought some things back. But one of the things that we do here is the cloud spends can sometimes get a little bit out of control. And what we are seeing is on the cost front, given that it's advantageous, for example, for AWS to run on Graviton 4, right? They can offer that at a slightly lower cost. So one of the things that we're seeing some customers want to do is, well, let's run my control plane on ARM-based systems, and then I'll run the rest on x86 until I start porting them across and start using multi-architecture compute. And this is where hosted control planes kind of comes in the mix. Now, this is not one of my technologies at all. As another person in the team looks after them, but it's definitely one of the things that I got excited about ARM from the OpenShift perspective. I think hosted control planes is something that customers may get excited about. And what it does is I'm going to really understate it just for the sake of simplicity. It takes your control plane, your OpenShift control plane, and turns that into a pod. So now you can run an OpenShift control plane as a pod. And this has got some really, and I'll get to the relevant point at the end, but this has got some really interesting designed in features. So if you're looking at cost, for example, you can do consolidation now. So the standard OpenShift install is 3 control plane nodes and 3 compute nodes, as we call them. With hosted control planes, you can consolidate those control plane nodes down into pods. So you can get 4 or 5 clusters running on a single system if you really wanted to, and that gets really interesting in definitely development environments, right? So you can just spin them up because it's a pod. An OpenShift install probably takes 10 to 30 minutes. Because it's just a pod that you're spinning up, you can do that in maybe 5 minutes or something like that. So, we're all used to, at least I am, you go onto a website and you say, click, give me something. And as long as it's Amazon Prime or something, you get it the next day, right? Well, you want that with your clusters as well. So
Yeah.
you can do that with hosted control planes. So that'll give you, this really is the idea of clusters as cattle rather than pets, if everyone gets that analogy. The other thing that's interesting is that it brings a different security model there that I won't go into. But the reason I'm talking about it now is one of the things you can do with hosted control planes, which we support both versions of now on the self-managed, is you can have a control plane of one architecture and the compute nodes of a different one. So that scenario that I started off with, where I want my ARM-based systems to be ARM-based systems. Here we go. It is late. I'm going to use that excuse. I want my control plane to be a set of ARM-based systems, and I want my compute nodes to be x86. You can do that with hosted control planes, and where that gets super interesting. So we did a joint presentation with one of our customers and Microsoft at Summit this year, and they were talking about, I think, they were kind of hedging a bit, but they said between 10 to 20% saving if you used ARM nodes. Now we look at some of the customers' cloud bills these days, and they're in the hundreds of millions of dollars spec. And if you can go in and say to them, look, you want to migrate over to ARM in the cloud, that's going to save you, even if you just lowball it and say 5% off your bill, that's a really, really interesting proposition.
Yeah. 5% of millions is still a lot of money.
Yeah. So I think there's lots and lots of opportunity there for customers. And again, I think what ARM's done really well. I was chatting to one of your colleagues was because I'm trying to write a blog, just to set up this series that we're doing about OpenShift on ARM, and I was kind of pinging them and saying, what applications don't run well on ARM? There must be some that you're suited to. And he's like, no, you're 2 years late to the conversation now. You need to we run everything very well now, so there's nothing to stop customers kind of moving across.
So, what kind of trends are you seeing from your users and customers for how they're managing their migrations?
So most of the stuff that we're dealing with right now is kind of nibbles around possibilities, and it definitely, the trend is, I've talked about this mixed architecture stuff. I think it's just a stepping stone. The trend is definitely entirely moving over to ARM for the reasons that we've talked about already. It's just it's the speed of movement that we're seeing varying. There's one customer that I talk to where they want everything on ARM-based systems. The devices that they have and the things that they manufacture. Um, the kind of test and dev and prod, the data analysis. I mean, AI. I haven't even said AI. How bad is that for a program, right? That we haven't mentioned AI yet. So all the things there, they kind of want to do it instantly. We've got others that are just picking certain areas. So the customer that I presented with Microsoft at Summit, they're a good example in that they see the value of ARM, but they've got one central application, and it's like their central nervous system and brain combined. And that one is at the moment, you know, uh, something they don't want to change. It's going to be very risky for them to re-architecture, rebuild it. So that's going to live on x86 for now. And that has to be in every single cluster, but they want the rest of the infrastructure around it to be ARM based, so that they're kind of interested in that. They go away and do that. And to give you an idea of what they've done, they took the environment first just on x86 and tested how it ran in Azure, and they were good with that. Then they started introducing ARM nodes and doing performance testing on that. I won't be admitting anything that's confidential to say that we found a few issues of performance on our side, because they're going to scale really big. Networking's always kind of interesting for us, but we're in a really, really good space now thanks to them. And now they're getting ready to kind of roll this out. And again, what was interesting for me was they're kind of running two clusters in parallel. So there's a production one where they're doing their day-to-day stuff, and then they've got this one kind of running at the side where the data is duplicated and run through, and they'll make sure that it's all true and nice, and hopefully things will go live sometime next year.
Very nice. Yeah, we do hear a lot about people make the switch, and they think you look at the just straight like CPU speed between the x86 and the ARM, but a lot of times you're running software that has spent decades sometimes being optimized for x86. We've had people on to talk about the optimizations they're doing in .NET and in Java. And in most of those cases, they're recreating the same kind of optimizations they've been adding to those languages for x86 for years. So even if the CPUs are as fast, sometimes the software is not ready to take advantage of that yet. But a lot of work happening now to make that possible and to make that easier too. So if you write an application in Java or in C#, that it's just gonna, you can compile it directly for ARM, and it's gonna have the same kind of performance on an ARM CPU as it would an equivalently clocked x86.
It's interesting you mention that, because we kind of hit a similar thing, and it's sometimes just about timing on stuff. So I think it was when Graviton 3 came out. There was this process where there was some things that we did in RHEL to kind of speed it up, but that work had to be done, and then you had to get that into OpenShift, and then we had to get that out, go through all our testing and customers. So there was I can't remember which release it was, but there was one release where we didn't run really well, and then one of our Z streams came out, and suddenly performance just went up a notch and things. So sometimes it is just down to timing and managing the stream, because just like with ARM, in OpenShift, what we want to do is give you an enterprise class experience. So we're not just going to rush something out the door. We're going to make sure that we're usually pretty close behind the community Kubernetes upstream, like maybe 2 months behind, something like that. But we do all that due diligence in that time. So when new stuff comes along, it sometimes takes us a little bit to kind of catch up. And I don't know, I always like it. You tend not to hear it, right? I don't know what it's like for you, but definitely when you're in product management, it's the problems that you hear about. You don't always hear about the successes, but it's nice when someone rings up and, oh yeah, the performance is really good now. I don't know what happened, but in the background, oh yeah, we put a patch in there that made the difference.
Right, or like they upgraded to the latest version of Java, and now some of these frequently called functions like hash table lookups now run even faster because they've implemented some ARM intrinsics in the underlying code, and the application developer didn't have to do anything to take advantage of that. But that takes us back to what you're talking about at the very start about the ease of updating applications and rolling out those updates so that people can take advantage of all of these improvements that are constantly coming down the pipe.
Yeah, I mean, that's definitely been, from my experience working with the team. So we obviously try out things, and I just log on to my ARM cluster, couple of commands to do, and then, well, not my ARM cluster. I'm usually, because I'm testing multi-arc, I log on to my x86 cluster, couple of commands, and I've got an ARM node up and running. And then you need to just get some workloads on there, and there's loads there. I mean, as I said, I think we did an evaluation of the Red Hat stack, and it was all mostly greens anyways. But it's much better now. It always kind of it bemuses me sometimes because sometimes the messaging lags behind realization, but ARM's got such a good ecosystem now when you look at what's there, and I don't think there's any reason for customers kind of not to try it out, at least, and see if it fits their workloads. So.
Yeah, and in so many cases, all you have to do is recompile or rebuild your container. I was talking to one person at KubeCon. They had a Java application that they were deploying out with Kubernetes, and like, I want to migrate to ARM. How do I do that? I'm like, well, okay, you're Java first of all, so that's going to be easy. You just make an ARM container image, and he's like, okay, then what? Like, then you deploy it. He's like, no, but what do I have to do with my
Yeah.
code?
Yeah.
Nothing. Like, in so many cases, there's nothing you have to do other than recompile or rebuild that container image. And with multi-arch containers now, you can have both x86 and ARM, in the same container image, and that just makes deploying it even easier.
Yeah, and from our side, I'm back to my own message. I'll get a present off my boss for saying this, but from our side, you don't need to learn anything new on OpenShift, right? It's just
Right.
what you're used to and exactly the same. So go for it.
Exactly. All right, so Duncan, that brings us up to where things are right now. Do you have anything exciting or some new features or improvements coming down the pipe?
Yeah, so I think I touched on it earlier from the kind of layered products piece. There's definitely more stuff coming on ARM next year. Because we're seeing adoption increase, so we'll see those things come on. From my team's perspective, and this sounds a horrible thing to say, but for just pure OpenShift ARM clusters, we're done. It's all integrated into our CI. Any new feature that comes along in OpenShift will get picked up and tested automatically. So you'll get that support on ARM. There's some, nuance there in that if there's a new layered product comes out, we'll need to make sure they tick on. But that, from our team, from the core side, we're done and dusted there. So our focus is now moving over to this multi-cluster architecture, multi-cluster compute environment, and it's been out for 2 releases now, but we really do liken it to a sharp pair of scissors. So it's very powerful and they're very sharp, but we do kind of let you just run down the corridor all by yourself. And if you trip up and cut yourself, and what I mean by that is we don't do anything to kind of help you out with that. You need to be at least a good user to do that. So, if you've got if you've got this mixed x86 ARM environment, say, we don't do anything on the scheduling side to make sure that your ARM binaries just run on ARM systems. So we're going to be working on that. It'll probably be an operator that we have that will just go out and look at your environment and do that. We did kind of talk to the upstream Kubernetes scheduling team, but quite rightly, they told us to go away because they want the scheduler to run as efficiently as possible, and they don't want kind of any lag in there. So we'll go away and do that. It might be something like using labels or taints or something like that being set up automatically for you. A lot of the information is just there. The other thing we're looking at is builds, and that's builds on 2 levels. So we do have something called OpenShift builds that's probably going to change in the future. So we're looking at how you do that, so you can get, a lot of customers kind of use it to build little things. So make sure ARM's in those options. The other side is with multi-arc. I'm going to bore you with a discussion around payloads. So if you're running in a multi-architecture environment, you've kind of got 2 choices. So the first one is scheduling, and you just build binaries that are dedicated to architecture. So you build your x86 binaries, you build your ARM binaries, and then you kind of use taints and tolerances to kind of make sure they go on the right nodes. Another option that we're seeing some customers talk about, and the term fat binary used to be around a long time when I was young, but kind of building multi-architecture payloads or images. And that needs something like manifest listed images. So you've just got the one image that you use, but when it comes to running on the system, it pulls down the right one. So we're looking at how that building those images can be easier. So I know you've talked about multi-architecture images with Podman. It's kind of building that into the DNA of OpenShift. So for us, believe it or not, we have, when you go to install OpenShift, you have a choice of 5 payloads now. So there is an x86 payload, there's an ARM payload, there's an IBM Z payload, there's an IBM Power payload, and then the 5th one that we want to kind of get as the default eventually is one that contains everything. So we're looking at how we enable users to do that on their side. So if they decide that they really want, and this is where things get interesting, because I don't know about you, I always find customers are a lot cleverer than I am, and they think
Oh
of
yeah.
weird and wonderful things to do. So it's going to be interesting to see if they feel more comfortable with the, I'm going to have individual images and do some cool scheduling, or are they going to say, right, I'm just going to build this thing so it runs anywhere, and then you know then they really can do some interesting things with perf testing, right? They can run it on x86 environment or use multi-arc to have ARM in the picture, switch it across, see what's better. Maybe, I don't know, you start looking at your AI workloads because there's some great chips coming along for that. So you can make sure those get squirreled to the right place.
Hmm.
But if you need to overflow and you haven't got all the systems you need, then you can run on different architecture. There's kind of some really interesting opportunities. And that's one of the things that I like about Red Hat. We're strong about working in the community, but what we also do is keep a good eye and see what things give you options and choices, and then kind of try and help grow the things that are successful.
All right. Well, Duncan, this has been a fantastic conversation. Thank you so much for coming on. We do like to end our show with a shameless plug. So we give our guests the opportunity to plug whatever it is that you want to plug to our audience.
Oh, okay. Well, this is the easy one. Go and try OpenShift 4.14 that came out on October 31st. It's a great release. There is so much content in there that we can't even cover it in an hour and a half session that we usually have. So go and read up about it. I'll get the link to it if you want to have a try of it yourselves, and just go and use it. It's a great tool, and go and try it out on ARM, right? Because I want to see my ARM telemetry hits go up. So help me do that as well.
All right. And you've got a show similar to Innovation Coffee too, don't you?
Yeah, the OpenShift have a channel as well that we do on YouTube, and is it still called Twitch? Oh, there we go. How cool is that? You've got the link up. That's pretty impressive. So, yeah, there's all sorts of goodness on there. We do a similar sort of thing to Innovation Chat. One of the things that I wasn't used to at all, which I think is really good, is every release, about a month before the release comes out, we'll get all the product managers online, and we will talk you through everything that's in there. That's the hour and a half show. And then what we're doing twice yearly now is we'll actually take you through roadmap as well, so you can tune in. So there's never any excuse for not knowing what's in the OpenShift pipeline. It's all up there, and we've got all the recordings, so you can go back and what I like to do is see what I've said I'm going to deliver, and then see what I actually deliver 6 months later. That's always quite interesting.
That's really nice for openness and transparency. And I think this is something that Red Hat's, kind of always been known for, right? As being transparent and involving the community in the work that you do.
Oh yeah, I they will remain nameless, but in one of my old jobs, you used to have to get permission from one person if you wanted to do a roadmap session to a customer. So it's really refreshing to be in this environment. So it's good.
Nice. All right. Well, as always, I'm going to plug the ARM developer program. If you want to get more information about developing software on ARM and the different options that you have there, please join our developer program. We'll get you set up with the links to our various resources, including our developer hub, which has got all of our learning paths on it that you can go and do those kind of self-paced tutorials for a variety of different topics. It will also get you a link to our public Discord where you can join thousands of other ARM software developers who are chatting every day on topics from servers and cloud, like OpenShift, all the way down to embedded devices and microcontrollers, including hot topics like AI and ML. So I want to thank everybody who watched this show. I want to thank our producer, Gabe, who's running everything behind the scenes for me. And then once again, thank you, Duncan Hardie from Red Hat, for being a guest on our show. And I would love to come be a guest on your show sometime soon as well.
Oh, absolutely. We'll definitely talk about that.
All right. And then last reminder, if you like this episode and you want to see more, hit that like and subscribe button so that you don't miss out on future content from us. And with that, I will wish everybody happy holidays, nice end to 2023, and we will see you all in the new year. Bye, everyone.